that are designed to be run in succession from the left to the right on startup. They are calibration, data storage, and operation. Continue with calibration. This tab allows the user to change the calibration of the inputs. These three are very similar. They're linear relationships, so you can change the slope and the intercept of any one of the three inputs. That way, if you have a thermocouple, you can just calibrate it right at the beginning, and it's good. You don't need any cold water bath or cold junction while it's running. It's been calibrated. Some other things about the specific of that run is here. So that you can choose the test duration, and then the interval at which you want to take specific gravity samples. So this will warn you and take the data when it'll tell you every interval when to take the data. And this is for future use. When electronic flow valves are purchased, this represents the voltage of a closed and an open system. So this way in the future you could purchase a 0 to 5 volt flow valve, 0 to 2, it doesn't matter, the system will compensate. This is just data storage, so this is the file path and location. It's fairly straightforward. Both can be changed, but this is the standard startup that goes to that automatic. This is where most of the time spent in the program is seen, is on the far right, and when the program is actually run, you can't change to another tab, because changing those values during the run would affect the data considerably, so I stopped that ability. And this one shows flow rate, and these two are temperatures. The voltage seen by the meter, that specific at that time, is shown here, and the conversion to the factor that we're actually looking for is in this box there. And that's the same for all three of these. This section contains the date and time, as well as the specific gravity input. The light turns on after the interval you specified at the beginning. You input the value, press OK, and it saves it. This is the control section, which will be used in the future with electronic flow valves. However, at the moment, I program the system to indicate to the user whether it believes the valve should be opened or closed, depending upon the current values given. That way, it's kind of like you still get information as to whether you're getting what you want, and it'll tell you what you need to do. However, the ratio of the two valves still needs to be maintained by the user, and that ratio is input here if there were electronic. All right, this is just a picture of the block diagram used. I'm not going to go into any detail because it's big and it would be kind of hard to see. So I will take specific questions afterward. The computer is actually outside, just outside, running the code as we speak. So if you have any specific questions for me on the code, I'm happy to answer them outside. And I will hand off to Sophia Newton, who will be talking about safety.
As my team members mentioned previously, safety is a big concern of this project because we are using dangerous chemicals such as methanol. Both ingredients of that, both ingredients of that, methanol and potassium hydroxide, are also dangerous chemicals. Potassium hydroxide is dangerous if it makes contact with the skin or the mucous membranes of the body. The same goes for methanol and methoxide. Along with that hazard, methoxide vapors are also flammable, so if you have any electrical wiring that isn't insulated properly and it's low enough, it could cause a spark and it could cause a floor fire that could not be put out with water because you would need a special chemical fire extinguisher for that case, which ERAU actually has. As far as using personal protection equipment for this project, what we used was the PVC gloves, as you can see right there. That's to protect if you get some sort of acid backsplash, something onto your hands so it wouldn't dissolve into your skin. The chemical suit itself, we used it as a precautionary measure. It's not crucial. You could get away with just wearing a long sleeve shirt and jeans as long as you have those PVC gloves on. The full face respirator, we opted for that because you do need goggles that seal around the face just so nothing can get in your eye because that is a mucous membrane that can cause blindness, all sorts of horrible things you don't want to happen. And since we needed a respirator as well, we just decided to opt for a full mask for easier operation. And the cartridges, the respirator cartridges, are organic vapor and acid respirators.